I know you might not be finished with the bell work, and if that's the case, that's all right, but we're going to go through it together anyway so that I can try to keep us on track today. Number 1 and number 2 are same exact process here. To square a number without using a calculator, you want to split it up into its tens and ones and turn it into a binomial. So I would rewrite 37 how? 30 plus 7. And then I'm going to take that and square it. What is our pattern for squaring a binomial? What will happen to my first term? It gets squared. How do I get the middle term?
You multiply 30 times 7 and then you multiply it by 2.
Yes. So we're going to end up with 2 times A times B. So we're going to take those two numbers, multiply them together, and then double it. And then my last term will always be what sign? Positive. So we're going to have plus what? B squared. Perfect. When I'm doing this with a double-digit number like 37, I tend to square the first one and the last one and put them together since I've got a tens and a ones. So 30 squared is what? 900. 7 squared? 49. So I can just write down 949. That's less to add together later, right? All right, so I've got 949 plus, this is where I have to watch myself, because if I don't write down 30 plus 7, in my head I'll go, oh, 3 times 7. But it's not 3 times 7. It's 30 times 7. You'll end up off by a power of 10 there. What is 30 times 7? 210, and then we want to double it. 420. And then I just add those two numbers together. And I get what? 1,369. Nice work. Let's walk through the same pattern on number 2. I think number 2 is easier than number 1 because I'm going to go through the exact same pattern, but I'm not going to be able to combine anything. So once I do the square, multiply, double, and square, I'm done. So what would my first term be on number 2? 64x squared. My middle term?
90x.
Close. 80x minus 80x plus 25. Nice work. And then number 3 said solve. I almost always do my x off to the side just to keep myself straight. I don't write the area model, the box after this, if that's the way you're used to factoring. Keep rolling with it, that's fine. I use factoring by grouping up on the screen just because it takes up less of my screen space. But the process is exactly the same, and you're going to end up with the same final answer. I need two numbers that are going to multiply together to give me what? Negative 42, but that add to 19. What two numbers will do that?
21 and negative 2.
21 and negative 2. So these two numbers right here is how I'm going to rewrite my middle term. I'm going to keep the first term and the last term the same. So I'm going to have 6x squared plus 21x minus 2x. The order on those does not matter, just like it doesn't matter in the area model, minus 7. And now I'm going to group these together. First two get grouped. Last two get grouped. And I pull the GCF out of each of these. What is my greatest common factor for 6x squared and 21x? 3x. And that would leave me with what? (2x plus 7). Because if I take 3x and I distribute it to 2x plus 7, I get 6x squared plus 21x. I'm going to do the exact same thing to the second group. I'm going to pull that GCF out, but I've got a little bit more in mind now because I know what I need to have left over. I need to have 2x plus 7 left over. What can I take out of those last two terms? Negative 1. And that would leave me with 2x plus 7. So what are my two factors then?
3x minus 1 and 2x plus 7.
3x minus 1 and 2x plus 7, which means my solutions are what?
1/3
And negative 7 halves. Beautiful. Do you guys have any questions for me on the bell work? Okay. We're going to start section 1.2 today. This is a today and tomorrow lesson. There's a chance we'll have like one problem to finish up on Monday. However, I don't anticipate that, which means your 1.2 homework will be due on Monday because we'll finish it tomorrow. It's due at the end of the next school day. So you'll have today, tomorrow, all weekend, and Monday to look at this and work on it. As we go through 1.2, we're going to be talking about exponents and radicals. I'm going to talk along the way as far as, how you would type certain things into Canvas. Yes, ma'am.
We don't have a book for this class, right?
We do have a book. If you want to check one out and take it home, I'm happy to sign one out to you. Some people really like that. Most students end up taking the book home, setting it on their bedroom floor. It gets covered under gym socks all year, and they never crack it open.
So it's not like the ones you write in and stuff like that?
Correct. There's no workbook. It's a college-level textbook. And the reason, so last year I gave them to everybody. This particular set, and this is unfortunately not uncommon with college textbooks, they're really expensive and poorly bound, which means the more they get used, pages fall out, binding cracks, and I don't want you guys to be responsible for replacing a book when it's not your fault. So if you want one, because I know some people work with a tutor and the tutor wants to see the book, or you want to read the book, or your parent wants to help you, absolutely, I'm more than happy to do that. However, I have all the homework up on Canvas, complete with snipped pictures from the book, so there's no reason that you have to take it back. Does that help? Okay. Alrighty. Housekeeping while I put this first slide up. 3 reminders while you guys are copying this down. If you have not done so already, please get me your introduction video. I'm going to be watching these over the weekend and trying to learn all 150 students' names. But if I have it by this weekend, that's really, really helpful as I get to know everybody. Your 1-1 homework is due tonight. If you're struggling with it and you have questions about it, I'm going to try to save a couple minutes at the end. I've already had some great questions. If I don't have time for questions, send me messages in Canvas. If you go home tonight and there's still a couple problems that you're struggling with, submit what you have. You can always go back in and work through any ones that you have missed and resubmit that for full points. Okay? All right. Yes?
So if we go in to resubmit a homework, do we just do the ones that we missed, or do we do the ones that we got right as well?
I will leave that up to your discretion. I will go through and look at all of them. And if you got 1 through 6 right on your first attempt and you missed everything after that, and so you start with 7 and you go to the end on your second attempt and then you get all those right, I will make sure that your score reflects that. Okay? Some people like to see that all right on the assignment when they're done with it, and that's fine as well. I even have some people, if they only missed 1 problem all the way through, they'll just submit a comment with the corrected answer, and I am perfectly fine with that. I want to see that you understand the material. Okay? All right. So a quick recap of exponential notation. Anything to the 0 power is 1. This should probably have been on that common mistakes page because it still catches people, even at the graduate level. Multiplying by 0 gives you 0. Power of 0 gives you 1. Anything to the first power, we can write it without the exponent. Second power means we're multiplying the base by itself 2 times. Third power, we're multiplying the base by itself 3 times. If we have a negative exponent, it is the reciprocal. So a to the negative 1 is 1 over a. A to the negative 2 is 1 over a times another 1 over a, or 1 over a squared. There's another equivalent way that I could write this very last one. because my numerator is a 1, I could have 1 over a whole quantity squared. Those are all equivalent expressions with the exact same meaning. So far, so good? Cool. We've got one more screen with notation stuff, just as reminders before we get into some examples. Two bases that are the same, being multiplied together. We're going to take their powers and add them. So if I had a to the 7th plus a squared, that would simplify to give me what? Sorry, not plus, times. Oop. My bad. There we go. A to the 9th. A to the 7 plus 2. I put my addition sign in the wrong spot. There we go. When I'm taking a power to another power, we're going to multiply those two powers together. So x to the 7th to the 3rd power. What does it mean for something to be cubed again? What does it mean for it to be to the 3rd power? Multiply it by itself 3 times. So x to the 7th whole thing cubed means that I've got x to the 7th times x to the 7th times x to the 7th. So I'm going to be adding 7 3 times. This is why we're multiplying those pieces. And so I would get x to the 21. A times b, whole thing to the nth power. This is not the distributive property, but if you kind of think about it like the distributive property, you're going to end up executing it correctly. So we're taking both pieces then, a to the nth power and b to the nth power. So if I had like, I don't know, mp to the 4th power, that means I've got mp times mp times mp times mp. But m and p are also being what? Multiplied. So I've got m times p times m times p. So how many times are we multiplying m there? 4 times. And p? 4 times. That's why it's going to, again, it's not distributing, but that's why each of those get that exponent. So far, so good? Okay. Up on the right-hand side, division. Same exact thing as with multiplication. If I have a fraction that is being taken to a power, the numerator is taken to that power and the denominator is taken to the same power. If I have a fraction where I have the same base top and bottom with different exponents, I'm going to subtract those powers. And then, of course, we've talked about negative exponents already. Can you guys tell me an equivalent way to write this? Something else that would mean the same, very similar to what we wrote down on the previous screen.
1 over a in parentheses to the power of n.
Absolutely correct. 1 over a inside parentheses to the power of n. All 3 of those are equivalent representations. When we are doing problems involving exponents, well, and really for anything in this class, your answers need to be fully simplified at the end. When we're talking about exponents, if I have a negative exponent as part of my final answer, would that be considered fully simplified? No. Only positive exponents. So any negative exponents, you do need to move to the opposite side. All right, let's try a couple practice problems. We'll start off with some softball. I want you guys to work through these. Get through at least A and B. If you get through A and B and you have some time before I start going through them, continue on down the list. But I'm going to give you guys about 3 minutes Get as far as you can. On part A, I'm going to get x to what power? X to the 5th. And y to the 4th. Let's look at it real quick. So I've got my exponents here, 3, 4, and -2. 3 plus 4 minus 2. That's where my exponent of 5 is coming from there. And then I have y to the 3rd and y to the... What's the power on that last y? I'm looking right here. First power. So I take those two and I add them together to get y to the 4th. So far, so good? Cool. On part B, which piece needs my attention first?
3x.
Yes, 3x to the 5th power, because it's being squared. So I need to deal with that first before I try to combine it with anything else. Yes?
So would you keep it as 3x? Oh, never mind. Because I thought that 3x was going to be its own term because the variable.
Oh, yeah. So because we have the squared on the outside, I've got 3x to the 5th times another 3x to the 5th. Let me write that down here. So 3x to the 5th times 3x to the 5th. So we end up with 3 squared, because I'm going to have 3 times 3. And then x to what power? X to the 10th power, because I've got 5 2 times. All right. So using that as our jumping off point, my fully simplified leading coefficient would be what? 9. And then I'm going to have x to 10th, but then I want to write this as my final answer, 17th, because I've got 5 times 2, and then I have to add it to that 7 right there. So x to the 17th, and y to the 5th. That was the easy one. Okay. Let's talk real quick while I'm here how you would enter that into Canvas. So obviously I can just keep the 9 there, right? I can't really do superscript, the exponent script in Canvas when I'm typing in an answer. So what could you use instead if you want to do x to the 17th?
What is that called?
The little caret. It looks like a triangle that's missing the bottom. So you want to do caret 17, y, caret 5. I know it looks messy. I definitely prefer the way it looks on paper to the way you'll type it into Canvas. And when you get into that Canvas assignment with the directions, there is also a like, if your answer is this, type it in like this, so that you've got kind of a reference to look at there. Okay? On part C, will my leading coefficient be positive or negative? Negative. It's going to be negative what? Negative 8. And then I'm going to have x to what power?
9.
X to the 9th, y to the 6th, and z
15.
to the 15th. Look at you guys go. On part D, will I have a positive or a negative leading coefficient? And that's okay if you hadn't gotten there. Will it be a positive or a negative? Positive. This first set of parentheses here makes me think it might be negative, but what's happening to that? It's being squared. So I've got negative 1 squared turns into a positive right there. Let's go ahead and finish squaring this set of parentheses. That would be a to the 10th and b to the negative 8th. I almost wrote 20th, and I don't know why. And then let's come over here. This is going to be 5 to the 3rd power, a to the negative 9, and b to the 3rd. So what's my leading coefficient going to be? It's going to be a positive 125. A to what power? A to the 1st power. And b to the negative 5. Is that a fully simplified final answer? Yes, we're going to turn this into a fraction. So 125a over b to the 5th. Part E, positive or negative leading coefficient? Positive. Why positive? Yes. Anytime we have even powers, that means we're going to have pairs of things that we're multiplying together. So our sign is always going to come out positive, because anytime we have pairs, a negative times a negative will give me a positive. Odd powers, do we always get positives? No. Odd, you can get positive or negative powers. But with even powers, positive or negative leading coefficient, I feel like I'm misspeaking and I'm sorry. With even powers, we will only ever have positive leading coefficients. What will this positive leading coefficient be? 16. A to the 12th, b to the 20th, and c to the negative 4, which means my final answer is
16 to the 12, b to the 20th, over c to the 4th.
There we go. Over c to the 4th. Taking something like that and typing it into Canvas. When you have a fraction, it's going to be really important that you communicate to me which parts go in the numerator and which parts go in the denominator. We're going to use a slash as the dividing line between them, but when my numerator has multiple pieces, like 16, a to the 12th, b to the 20th, the safest way to make sure that you are communicating to me that that's all in your numerator, put it inside parentheses. So I would have parentheses, 16a caret 12, b caret 20, close my parentheses, use my slash. If there's only a single thing down in the denominator, like c to the fourth, you can put it in just c to the fourth. So c caret 4. I would recommend, and this is absolutely essential if there is more than one piece in the denominator, popping parentheses around that as well. So if it's more than just like 2/3, numerator in parentheses, then give me your slash so I know it's a fraction, denominator inside parentheses, all right? I've tried my best on Canvas to make sure that as I'm explaining it to you, how I want it typed in is exactly how the answers are, with some slight variations because I know fingers can slip sometimes. If you type in an answer and it is equivalent to what I have, but you have a different way of typing it in that I didn't think of, I will add that to the correct answers and you'll get full points for it. Even though these things are automatically graded, I still look through any of them that it marked you wrong on to make sure that it's actually wrong and not Canvas being dumb. All right. Take about 3 minutes, see what you can do, and then we'll go through them. I want to give you guys a chance to try it on your own first, but then I want to go through them, and I am really trying to watch the clock today. See what you can do with it. Yes, that is only an exponent on that last set of parentheses. Even if you're only done with the first one, that's okay. I do want to start talking about these so that I make sure we get through them all before the bell. I would focus on this last piece here, this last set of parentheses first, because it is the only thing that's being squared. So I'm going to have 4 squared, x squared, y to the negative 10, and z squared. So what will my leading coefficient be? 16. And then I would have x to what power? -4. Y to the? -3. Z to the? 5, 6, and 6th. Because there's that -1 in that first one. Z to the 6th. So final answer would need to look like what?
16 z to the 6th over x to the 4th, y to the 3rd.
Yes, 16z to the 6th over x to the 4th, y to the 3rd. This is an example of where you would absolutely have to have parentheses around your entire denominator because there's more than one thing down there. All right? Part G, there are so many different ways you could begin this problem as a step 1. When I look at a problem like G and I notice inside the parentheses that we have some common bases, top and bottom, I like to start by simplifying inside the parentheses if I can, because I like to make things smaller before I make them more complicated. So if I was going to clean up inside the parentheses, the 3 and the 4 stay put. I want positive exponents only. So will A be in my numerator or my denominator if I want to keep exponents positive? Denominator. I'm going to have A to the, what will it be? 5th. It would be A to the 5th power.
Oh, wait, we're moving them first.
We're going to move them first, and then we'll deal with that -2 on the outside. Will B be on the top or the bottom? Top, and it'll be B to the 8th power, and then C stays up on top. All of that to the -2. Again, this is not the only way to go about this. This is how I began this problem. There's multiple correct ways to begin this problem. From there, I'm going to deal just with the negative part of the exponent next. Negative exponents mean to do what?
Swap everything.
Swap everything. So I'm going to have 4a to the 5th up in my numerator now, 3b to the 8th c in my denominator. It's still squared, but now it is to the +2 power. The reason I like doing it in this order is notice I don't have any negative exponents here. So when I square each piece, that is my final answer, and I don't have to do any cleanup work at the end then. So what is my final answer going to look like?
16a to the 10th over 9b to the 16th, c to the squared.
C squared. Beautiful. 16a to the 10th over 9b to the 16th, c squared. Part H, there's really not anything I can clean up inside those parentheses. Anything I can combine, right?
Would you move them here first?
Would I move what?
Would you move the exponents here first, or the x and the z?
The x and the z. Oh, move them down to the denominator?
Yeah.
Actually, on this one, and this is why I say there's multiple ways to start them. If you start yours a different way, but we end up in the same final location, I'm totally fine with that. For this one, I would deal with this power of -3 first, because then I'm going to see which pieces actually need to move down to the denominator. So that's where I would start here. So I would have 4 to the -3 power, and then it would be x to what power? X to the 9th power, y to the -6th, and z to the 15th. And this, of course, is x to the -3 times -3. That's how we got that. So which pieces are going to end up in my numerator of my final answer? X and z. X to the 9th, z to the 15th, because those are the ones that have positive powers on them. What goes in my denominator? Fully simplified. 64. Y to the 6th power. Beautiful. All right. We've got about a minute and a half to the bell, so I'm going to stop us here. Tomorrow, we're going to talk about rational exponents. What does the word rational mean in math? Not necessarily. Fractions. If we're dealing with rational numbers or rational exponents, we're dealing with fractional things.
I'll get to your English.